Welcome everyone to the first Tech23 Impact Circle of 2021. It's so wonderful to have you all join us for what's sure to be a great conversation, which is actually the second conversation around quantum-powered industries. And we're going to be exploring what's next. Continue with the conversation that we had actually late last year in October. As is custom, I would first like to acknowledge both the Gadigal people of the Eora Nation and the Bunurong and Wurundjeri peoples of the Kulin Nation, the traditional custodians of the land where the Slattery's team meets, works, and creates. We pay our respects to the elders, both past and present and emerging, always was, always will be Aboriginal land. Now, today it is my great pleasure to welcome the contributors who will be led by Bill Bartee, including Professor Michael Biersick, Marcus Doherty from Quantum Brilliance, sorry Michael Biersick, you're from Q-CTRL, Chief Scientist Cathy Foley, Jane Garrett from the Quantum Technology Enterprise Centre from the University of Bristol, John King from Silicon Quantum Computing, and Peter Turner from Sydney Quantum Academy. Now you can check out all the contributor bios on the Tech23 website. Now in its 13th year, Tech23 takes pride in celebrating Australian innovation and is about amplifying the people and organisations chipping away at the big challenges we face. The Tech23 Impact Circles are a fantastic forum for curious minds such as yourself to come together around the big opportunities we have in Australia to create new industries, smarter solutions, and a better world. I would like to take this opportunity to wish all those on the line a very warm welcome, particularly to our contributors. Now, just a couple of housekeepings items before we kick off. You will have seen in your reminders and in the Zoom chat, there is a link to the Slattery's Community Charter, which is a good indicator of what kind of behaviour is encouraged in all of the circles. We are also using a shared mural board to capture your thoughts, which we are sharing in the chat in Slack. Please free to add all your squiggles and post-its or insights, whatever you like, to this board. Please feel free also to ask any questions via the chat function in Zoom, or just put up your hand to ask live. Now, after Bill and the contributors share, we will take some questions from you, and then we'll have the opportunity to break into small but continued conversation. Oops. Finally, as a side note, we will be recording this session, so we will make
no worries whatsoever.
You can revisit and share later on. Now, without any further ado, I'd like to welcome Bill to kick things off. Thank you, Bill.
Well, thank you for that ginormous clap. Thanks everybody. I really appreciate the opportunity. Just one housekeeping thing. Whenever anybody, thank you, Andrew. Whenever anybody is speaking, maybe if we could all be on mute, that would be great. That would help and not distract everybody else. So thanks for that. Look, it's a real pleasure. I have the easy job here. I just get to ask questions and introduce everybody, or at least have everybody introduce themselves. What we have here is we do have a layer of some of the top experts in the quantum industry on the phone, on Zoom in Sydney and other places. So this is a terrific forum for you to ask your questions and get a really good overview of the quantum industry and sort of carry on from where we left off last time. And so the way we want to run this is I'm going to ask all the people who are going to speak a little bit and answer questions to introduce themselves briefly as to who they are and what they do and what their company or position does. And after that, what we will do is we'll start to ask some questions. I'll start off with a few questions, and then as people add questions to the mural board, which is in your chat, we can address any of those questions as well. So the idea is to help you understand the industry, help you understand what the opportunities are, where to go find an expert if you need to, and really understand what what this is all about, because I think we all believe that Australia has a wealth of talent here, and we want to be able to capitalize on the opportunity. And this is a community effort to let everybody level up as to where we are. So without further ado, maybe I'll just go around in a fashion as to who's first on my Zoom screen. So Jane, can I ask you to introduce yourself first and tell everybody who you are and what you do?
Oh, thanks, Bill. Hello, everyone. My name's Jane Garrett. I'm currently the Deputy Director for Enterprise at the University of Bristol's Quantum Technology Enterprise Centre. So I have to refuse being a quantum expert, but being an expert in quantum commercialization is probably more to the point. The Q-Tech program was grant funded, and it's actually in its demise, unfortunately. So I'm actually now living in Australia. I'm not in Perth, Rachel. I'm in a beautiful place called Shark Bay. And I'm winding down my contract, finishing on the 30th of June. Q-Tech has created, I've got the stats, if you don't mind me telling you, because we like to brag about it. So on a 4.4 million grant, we've raised 46 million in terms of equity, revenue and grant funding. We've created 23 businesses out of 40 that started the program, and 126 jobs have been created, and that is still growing. Because as I say, we don't finish till the 30th of June. But unfortunately, then it does finish, and that gives a wide opportunity for Australia to jump in.
Great. Thanks, Jane. That was terrific. John King, you're next on my screen. If I could ask you who you are and what you do.
Thanks, Bill. My name is John King. I'm the Chief Operating Officer of Silicon Quantum Computing. I've been here since since December 2017. I really bring, like Jane, I'm not a quantum physicist. I bring business and commercial skills. I spent 30 years as a corporate lawyer and financier, and some time in venture capital and private equity. And then about 10 of those years was spent with technology, innovation and startups. So I bring all that experience to what is a fabulous technical team at Silicon Quantum Computing, led by Michelle Simmons, the Australian of the Year 2018. Silicon Quantum Computing is trying to make the world's best operating quantum processor. We have $83 million from the federal government, New South Wales state government, Commonwealth Bank, Telstra and the state of New South Wales, which we've been expending since May 2017, working steadily on a technical program to deliver a 10-qubit integrated circuit in the end of 2023, and ultimately a silicon quantum computer. The research we do here is built on over 20 years of research that was done at the Centre for Quantum Computing, who we're co-located with at the wonderful UNSW facilities, state-of-the-art world-class facilities here in Kensington and Sydney. We employ around 35 researchers at the moment from over a dozen nations and half a dozen people in our corporate centre. It's quite a big team. And yeah, we're very much focused on a plan that we have to deliver the processor and working through that. This year, we're going to turn around a little bit too in the corporate side and be a little more focused on, we've got some capital we're going to have to raise on developing some more collaborations around those aspects of the stack that we're not necessarily touching, and looking at the inputs that are required for quantum computing and how we access those, particularly in this ecosystem.
Yeah, great. Thank you, John. That's terrific. Next on my screen is Mike Biersick. So Mike.
Hi, it's nice to be here. My name is Mike Biersick. I'm the CEO and founder of a company called Q-CTRL. I'm also by background a professor of quantum physics and quantum technology at the University of Sydney. My career was spent primarily on learning how to make quantum technologies useful through quantum control. We build quantum computers. We operate the most powerful quantum computer in the Southern Hemisphere in my academic team. And we've taken all those learnings and use them to form a company that started in November 2017, focused on deploying quantum control in quantum computing and quantum sensing for the global market. We currently have just about 50 people on staff. This includes our members of the team in our Sydney headquarters, as well as our US headquarters in Los Angeles and a new office in Berlin. And we're growing very rapidly, looking to expand that to almost 100 people in the next 12 to 18 months.
Yeah, great. Thanks, Mike. Cathy Foley, you are next on the agenda here.
So hi everyone, it's great to be here. Cathy Foley. I'm now Australia's Chief Scientist, but before that I was CSIRO's Chief Scientist, and in that role I helped develop the quantum roadmap, which we can talk a bit more about later. But But my background is in superconducting electronics. So I've made quantum sensors for magnetic sensing and developed them for a range of applications. The most successful commercial one is one for mineral exploration called LandTem, which has been responsible for the discovery of billions of dollars of different mines, from Cannington silver mine up in Queensland through to nickel sulfide mines in Western Australia and in Canada. In my role as Chief Scientist for Australia, one of the things I'm working towards is getting a Commonwealth Government network or way of actually pulling together a whole lot of different things that are happening across Australia in things quantum. Just this morning, I had a meeting with all the chief scientists in all the different states around us and territories in Australia. And everyone's joined up to say, let's see how we can collectively come together to really pull this opportunity into something which is supported, so that the opportunity which was identified in the roadmap is there for the taking, and that we can realise it, making the most of all the sorts of things that we're going to hear about this afternoon, and see if we can really push that through. So that's where I'm coming from. It's great to be here. Looking forward to the discussion.
Thanks, Cathy. Marcus Doherty, you are next.
Thanks, Bill, and good afternoon, everyone. So I'm Marcus Doherty. I have 3 different roles, which I'll try to briefly introduce each. The first one is I'm a co-founder and the Chief Scientific Officer of Quantum Brilliance. There I drive the R&D required to scale up the computational power while scaling down the size, weight, and power and cost of our quantum computers to ultimately be something the size of a graphics card in the next 5 years. So therefore delivering supercomputing levels power in a graphics card size device for select tasks. And this motivates a very different picture of where and how quantum computers can be deployed, as well as when they'll deliver practical advantage over equivalent classical computers. Quantum Brilliance is a team which has rapidly expanded over the last 12 months and now employs over 20 full-time people, and we operate across the world. We have multiple partners around the world, and we're expanding into Germany this year. Another role that I have is I'm the head of the Diamond Quantum Science and Technology Laboratory at the Australian National University, where my laboratory develops technologies across the spectrum of sensing, microscopy, computing, and communications. A third role, which might be particularly relevant today, is I'm a part-time Army officer, and I work within the Future Land Warfare branch of the Australian Army headquarters. So there I help the team drive Army's engagement with quantum technologies, how we think, how we are going to seek advantage, and how we're going to exploit that advantage for Army's benefit.
Yeah, great, many hats, Marcus. Peter Turner, can you introduce yourself, please?
Yeah, sure can. Thanks, Bill, and thanks, everyone. Good afternoon. My name's Peter Turner. I'm the CEO of the Sydney Quantum Academy here in Sydney, and I also have a position in the quantum engineering group at Macquarie University. I'm a quantum information theorist by training. To overlap with Jane, I was in Bristol before I came here, and I think part of the reason I was asked to come and head up this amazing academy initiative was that we were training one of the first quantum engineering training programs in the world there in Bristol 7 years ago, really focusing on quantum talent and this transition that the field is making from a very purely academic endeavor into a more commercial and industry endeavor. And we were training people for exactly that kind of transition, and that's exactly what the Sydney Quantum Academy is looking to do. Very much about people. Our vision is building Australia's quantum industry, and that there's a lot to that. We're a small team right now, but we've got, for example, a PhD training program that we put together across 4 partner universities here in Sydney, UNSW, Macquarie, USydney, and UTS. So that's quite amazing, where we can get those, individually those 4 institutions have amazing world-recognized quantum research groups. And it was recognized by the New South Wales government that together it's a real powerhouse. It's a global one of the highest concentrations in quantum expertise on Earth here in Sydney. So we sit in the middle of that, and we engage with on the training side, on the academic side, with government, and with industry and entrepreneurship as well. So really looking forward to the conversation today and ways that we can help move that vision forward.
Yeah, great. Great, Peter. I thought maybe what we would do is just start from a very high level. And I know Cathy did when she was over at CSIRO, did a study and put out a paper called the Australian Quantum Roadmap, which is in the link in the chat box if anybody wants to download the document. But Cathy, can you just give us a high-level view of what the quantum industry is like in Australia and what the opportunities are that you see going forward? We don't need to go into big specifics, but just a quick high-level overview would be awesome to hear.
Yeah, sure. So I'll first of all start with the market opportunities and then go to what Australia has. So basically, this came about from the quantum community in Australia coming together and saying, how can we work out where to go to next and work collectively? And so we were able to get funding in CSIRO to use our what was CSIRO's Futures program to develop the roadmap. Basically, it's been identified there's about an $86 billion projected quantum technology in the global market, they say by 2024, so that's not that far away. And we've identified through the process of doing this road mapping that Australia could capture, and this was a very conservative approach, but we decided it was important to be conservative, that we could capture about $4.3 million of that opportunity by 2040. And again, it was very conservative, and already I'm seeing things accelerating that I think that we'll probably revise that in an upwards way. But it would also create about 16,000 high-value jobs in Australia. And Australia's investment in things quantum is significant by Australia's standards, but there are other countries around the world, just about every other main research country, significantly investing in quantum technologies and the research for them, and also particularly looking at how to add that to their arsenal of potential new industries. I think the thing that's really interesting is that we've seen as a consequence of the excellent work here that's been done in the university system, and the ARC has been a major funder of this, as have in some cases investments from state governments as well for the fundamental work. But what we're seeing is that getting to a level of maturity so that already there's a number of, first of all, spin-out companies. I guess Quintessence was one of the first ones where they're looking at quantum encryption and security, through to, you've heard today from, and we'll hear more from Michael Biercuk with Q-CTRL, and Marcus's Quantum Brilliance Diamond, what is it, NV Diamond accelerator, and something where I guess is really interesting to see is the rate of change and improvement, even since that roadmap, which was released 12 months ago. But I think the thing which I'm finding most exciting is we're seeing multinationals coming into Australia. So we've got Microsoft, who's set up a big connection with Sydney University, and I'm sure Peter Turner will be able to go into more details about that. We've got IBM, who's linked in very closely in Victoria and with Melbourne University. And they're doing some pretty exciting things, which are making their toy quantum computer available on the web, so or on the cloud, so that in the last year, 300,000 people have gone onto the IBM QuizKit, QISKIT.org website to learn and do training on how to use it. It's not fully error corrected yet. It's a sort of an early stage quantum computer. And but the thing that's really interesting is they're developing 20,000 apps on this, or applications, and finding that when they combine that very early stage capability or quantum capability with supercomputing and classical computing, they're already seeing acceleration in and capability you can't just do classically in 3 areas. In designing new materials, because you can do true quantum simulations. And so, for example, designing a new COVID vaccine would be an example of application being developed. Another one is enhancing artificial intelligence and machine learning, being able to do computational work you just can't do on a classical computer, regardless of how big it is, and adding that some of the opportunities that quantum capability can provide. And then the other one is interrogating databases so that you're able to do searches in ways you can't currently do with classical computing. So that's there available now, and Google is doing the same thing. Another thing that is interesting is seeing the attraction of people such as John Martinez, who was probably the leader of the Google quantum computer development. He's joined Michelle Simmons' group, and I'm sure we'll hear more about that as well as and also we've got to a point where there's great interest and I think entrepreneurial spirit where researchers who in the past might have just considered only an academic career are now hungry to take their quantum technologies into the market. And I think the role that Main Sequence Ventures have played in really not just with supporting through being a funder of like venture capital funding in particular industries, but it's also the work you've done in just bringing up that maturity of what does it mean to commercialize something, even if it's something you haven't done. Those, like I think you call them office hours. So I guess that's where I'll leave it.
Yeah.
Is that we identified this to be a very rich area. We've got state governments willing to do this. The federal government's about to come in with an approach which isn't ready yet because they've got to do all the stuff behind the scenes, but we're looking to have that sort of some sort of way of bringing all the great work together in a way which allows us to have a common, I guess, visibility when people are looking from outside Australia into what we've got to offer, and having and sort of seeing how we can knit that all together into a more cohesive offering.
Well,
so back to you, Bill.
Yeah, no, that's really great, and I think we're really lucky to have Cathy as the chief scientist, who also has worked in the field and is such a great proponent. So we're in a fortunate position there. Hey, Peter Turner, you're a little bit new to the country and to the area, but I heard Cathy, and I've who's an insider, as well as all the other people, Mike Biersick and Marcus, who are insiders as well, say, talk about the strength that we have here locally. But as an outsider who's just recently kind of joined from Europe, what have you observed about the strength of the quantum field across the board here? What's your early impressions?
Yeah, well, thanks. I did. I just got out of quarantine before Christmas, everybody. So I'm out. And it's a pleasure to be here. Yeah, it'd be a little unfair for me to say what my first impressions are, because I have been visiting and aware of the Australian quantum community as an academic for many years. So I do know a lot about the amazing research that's gone on here. So, I mean, and that just speaks to the quality of it. I mean, it is absolutely international level research, just world leading in many different areas. I think what's especially interesting in Sydney is the amount of goodwill across. I mentioned these 4 institutions that are partners in the Sydney Quantum Academy. Those are 4. Technically you could look at them as competitors, really, in the university space, and yet in the quantum community inside those organizations, there's just so much goodwill about getting this community moving forward. Training people, that talent pipeline, it's absolutely critical for this future industry that we're all interested in and really hopeful in seeing be created. So an interesting question I've been asked a few times now on meetings around when I introduced the Sydney Quantum Academy, and again, this amazing concentration of quantum tech expertise here, is Australians asking, why is it that Sydney and Australia is a world leader in quantum tech. And I mean, I have a very biased opinion, and maybe I'll float this out there for the rest of the panel, can talk about a little bit later on. But from my background, it just speaks to the investment in fundamental science. I mean, the quantum optics efforts that Australia made in the 70s and 80s, and that connection to that led to where a lot of the founders of quantum tech and quantum information came out of, has just meant Australia has been at the leading edge of this thing since day one. Yeah. So you know, that we're leveraging that now. We're seeing the payoffs of that now, and that's why we're here in trying to move that forward into commercialization and entrepreneurship and industry engagement and all of those things.
Yeah, great. And look, I know we have a number of people from the corporate world sort of on the call. Just be interested in the panels. This is not directed to anybody specifically, but what do we see? So two-part question. How does somebody, if they're thinking about quantum, they've been reading about it, they know it's going to have applications to their business. One, how do they learn about the field? And two, where do you see some of the applications, especially, you know, in the finance or the chemistry or the materials field? Where do you see these applications? Where does quantum, on the compute side at least, have applications? What are some thoughts there?
Maybe I'll jump in with this. So it is a difficult field to penetrate, and I think this is an experience that everybody who comes from you know, a background that is not a PhD in quantum physics and quantum technology will experience. We actually at Q-Control saw this for many of the people who reached out to us, people who were just asking if they saw me on a panel or something, how do we get into it? As a result, I mean, we ended up building two things. One, a learning center that's at qcontrol.com, where there are, you know, videos that are professionally produced trying to help people begin their quantum journey. But then we actually decided to build a whole product that is like Duolingo for quantum, with Chris Ferry, who's the author of Quantum Physics for Babies, as the content developer, helping people who are, you know, experts in whatever their field is, or professionals, mature professionals who want to get started and get into the field. So that product is targeted at enterprise. And it itself became a business opportunity that is peripheral to our core activities. But the reason that people keep asking, the reason that there's so much interest comes, as Bill was alluding to, from the applications that have been identified. Now, I do want to point out, quantum technology is much more than quantum computing. The thing is, we talk about quantum computing because it's the sexiest, it's the investor zeitgeist, it gets a lot of the media attention. In quantum computing, we have huge opportunities to transform the way we perform computations in areas like chemistry, pharmaceutical drug discovery, in optimization, in logistics and transport. Some of these problems are just effectively impossible, even for the biggest supercomputer that you could conceive of. And it is our understanding, based on all the evidence that we've accumulated, that some of these problems are efficiently tackled with quantum computers. Now, that means things that you just couldn't ever solve, like how do I make a protein that folds exactly the way I want, or how do I make a drug with the certain properties that are relevant to curing a disease? Those problems can come within reach, right? It's useful to say that takes a lot to get there. It's a really hard journey, and there's a lot more work that needs to be done. But the early demonstrations are exceptionally promising, from Google's quantum supremacy, as it's called, experiment, to the efforts in IBM and others to make quantum computers available online. But then there are these other things. Cathy mentioned briefly the idea of quantum sensing, using quantum systems to detect very small signatures. And this is exceptionally useful in minerals, in defense, in aerospace. I mean, we happen to have a big program in precision navigation, making quantum sensors that are useful for inertial navigation, so you can have autonomous vehicle networks that operate in GPS denied environments, like in a military theater. So there are all these different applications that are really relevant, and every single one of them provides transformational capabilities. That's why there's so much excitement these days.
I might add a little to what Mike said. I think there's a world around quantum beyond what the quantum physicists and what the technologists are doing. I think you sort of carve it up a little bit. People, I mean, Quantum Academy is a great initiative, and Billy, Peter, and congratulations, and others who've been behind that. There's going to be the requirement for a lot of other people as well, technicians, engineers, those that work around the quantum space, either on the input side or on the engage, and certainly on the output side, the user side. There's going to be a need for a whole raft of IT professionals who are going to be the ones who really interpret that and use the technology once we deploy it, and build it into industry. So there's a whole different groups and classes of people that can be involved in and we need to start getting those people ready now, thinking about training them beyond just what the Quantum Academy is doing, although maybe that's something that they might segment into as well. The second thing is money. Look, it's an expensive enterprise. All of us are going to need capital. Obviously, I'm talking to a provider of that, but and it's going to start with venture capital and with government funding, but gradually, as we move closer and closer to full commercialization, there's going to be a need for all sorts of different types of capital. Some will have seen the interesting news about IonQ going public today or yesterday. Very sort of interesting to see that we've already got some quantum companies. Bill, you look like you're smiling. I might be smiling too, but we'll see. It's an interesting thing. Yeah. It's an interesting thing that will happen. We can talk about it later. Suppliers. I think one thing that we don't focus as much as maybe we could on is the various industries that will sit around quantum. Some may know that SQC has a joint venture with a company, or a CRCP project actually, with UNSW and a company called Silex System to make our core input silicon 28, silicon 28. Those sort of activities is an opportunity for a much broader group of industrials and companies in the economy to get involved. And finally, I think the ecosystem itself, I think we have to be careful about thinking in a reductionist way and just thinking of it as the quantum physicists and us to work with them, but rather think of it really broadly as government, as well, I guess they're probably in there already, but as other companies, as individuals who might be interested. I think there's quite a rich opportunity for those that aren't necessarily PhDs in quantum physics to get involved, and I think that's evolving pretty rapidly too. So there is the opportunity there.
Yeah. So great, John, and I'll let you chime in just a second, Marcus. But what you're saying is effectively that to enter the industry, you actually don't have to have a PhD in physics. You can be an electrical engineer. You can be somebody who can operate a refrigerator, and there's all kinds of opportunities. Is that correct? Maybe you can expand on that, Marcus.
Yeah, thanks a lot, Bill. And I think I'd like to build directly upon what John was saying. And so thanks, John, for leading it into that. So I am biased, but I will say it as I see it. I believe the Pawsey Quantum Brilliance Innovation Hub is a shining example of how to construct a sovereign industry. And why do I say that? I say that because as was announced at a major supercomputing conference a few weeks ago at Supercomputing Asia, Pawsey is undertaking a field trial of Quantum Brilliance's quantum computing hardware within its data center later this year. Pawsey has also deployed Quantum Brilliance's software architecture and its software emulators on its high-performance computing system, and is undertaking a program called the Pawsey Pioneer Program. Now, what has that done? So it has given Quantum Brilliance an objective, which is a very important commercial and also technological outcome. As a result, we have created a supply chain of contractors and also material suppliers in order to deliver upon that. So we've developed a sovereign supply chain to deliver that. And the outcomes of that field trial and also the provision of those software architecture and emulators on Pawsey is we now have an ecosystem which comprises of both industry partners as well as research partners who are now developing applications for quantum computers using that facility. And those industry partners are also not from the quantum industry. These are people from the advanced AI machine learning industry who are using our systems to develop solutions for defense. And then we also have other quantum startups who are catering customers and logistics, as well as researchers who are doing explorative work about advanced applications. So that, I think, is a perfect example of how you can take a public institution like Pawsey and an implement initiative which builds industry and also provides access for people who are not quantum experts to really start to develop applications for customers.
Yeah, great. Hey, there was a question in the chat about, if Australian corporates are actively engaging and buying from the quantum industry startups here locally. Now, I know that, I'm aware of a few customers that some of the companies have, but without disclosing anything confidential, can we speak to that? Is there any interest from the local community in buying from the local startups and the local quantum industry? What's been that experience from everybody?
I think the reality is it varies, and it's a great opportunity to have much better engagement from especially the corporate sector in Australia. We've had an experience that government agencies have actually been very keen on what we do and have purchased, not granted, not given grant funding, have purchased license agreements from some of our core software. This has really been forward-looking in parts of the government that are interested in adopting advanced technology. And we've had great experiences with local small businesses that are building really advanced technology. We have one publicly acknowledged engagement with a company called Advanced Navigation. They make inertial navigation systems that are used in autonomous vehicles and the like. And they were very keen on building a new kind of system with enhanced performance for long-term GPS denied environments, whether that's in space or deep underwater. And they came to us, and we've been working directly with them as a commercial client of ours, delivering new next generation quantum sensing solutions. So there are parts of the ecosystem that are extremely engaged. And I think there's a great opportunity for local incumbent industry to capitalize on this technology base as well.
So
Yeah.
Bill, I might offer a perspective from Army. So Army why is Army interested in quantum technologies? Because of the potential technological benefit, but there's also a thing, and that is that quantum technologies are very complex and they're also very diverse, and the applications aren't quite clear. And there's a standing hypothesis that those who identify the applications first are going to get an early quantum advantage. And if they reinforce that, be able to maintain that quantum advantage over adversaries. So as a result, the Australian Army is trying to be quite agile and quite forward-leaning and really engage with the quantum industry in order to find those applications first. And as a result, we created the Quantum Technology Challenge, which is running at the moment and will culminate in the Chief of Army Symposium in April. And that is that first step in application discovery. Now, how does that fit into what you were talking about? That fits in because it's about putting the industry to work. So it is about asking the industry to deliver on contracts. As a result, they partner with other companies, they partner with researchers, and in future phases of the challenge, we'll see those companies partner with larger integrators. And as a result, through putting the industry to work, we are generating those interconnects, we're generating that synergy of capability to deliver on those technologies once they develop in full.
Yeah, great. And Marcus, it may be, might be a bit late for this sort of round on the challenge, but if somebody wanted to find out more about that, is there a place for them to go and figure out whether they can participate, have some industry participation with Army? How does somebody find out about that?
Yeah, sure. So the current round is closed. There was documents on AusTender, but there was also documents on the Australian Army Land Power Forum, which you'll be able to Google up. And there will be future rounds of the Technology Challenge. But stay tuned for this event, which is the Chief of Army Symposium in April. There'll be much more information coming out about the challenge participants, what the challenge is, and also Army's larger roadmap for engaging with quantum technology.
Yeah, great.
Actually, Bill, it's Cathy here. One of the things is interesting is I know in general across all the defence forces, there's an uptick in interest in, not interest, there's there, how they had the star shots, of which quantum sensing was one of them, and looking particularly at GPS denied areas as being, or sensing or capability as being a major focus. they've now, just because of the rate of development of things quantum globally, they're actually in the process of upgrading their planning and intentions for fast tracking engagement in quantum across all forces. So you'll be, Tanya Munro will probably be putting out a call for a broader broader strategy in the next little while, because and the thing that's really interesting was the Starshots were announced about a year ago, and it sort of has highlighted to me just things are changing really fast. So I know, for example, that roadmap I did last year, it's out of date already, and it's one where I think from my perspective, it's pretty exciting to see the fact that it's this bottom-up movement is really taking over in a way which I didn't realize was going to be as powerful as it is. I thought it had a lot of opportunity, and I thought was prospective, but actually it's rapidly changing to being, and we're hearing it already, but delivering in ways which I think a lot of people thought was not possible in the time frame.
So
Yeah.
Bill,
Yeah.
I wanted to chime in with one quick thing. Just based on the way the conversation is going, and I'm guilty of it myself. We've talked about GPS denial. We've talked about precision navigation systems. We've talked about advanced data centers. I think it's pretty easy for many people, especially in the industrial setting, to say, look, these very techie things are awesome, but that doesn't apply to me. And I want to reset that bit of the conversation, because quantum technology touches absolutely everything. And quantum computing, as one particular example, really does have the ability to touch almost everything. And part of that comes from the fact that the technology is maturing at a level where you can, in fact, log on via your laptop and execute calls via real quantum computers available on the cloud. This is not only technology that exists in academic laboratories, right?
Yeah.
This is not only for the handful of people like me or Marcus or Peter who have worked in this and have PhDs in the field. This is new computing technology that is exactly as accessible as AWS is, right?
Yeah.
Or as Google Cloud is for anybody else. Now, there's time yet until we get to this threshold where we achieve what's called quantum advantage, where it is actually commercially advantageous to choose the quantum solution over the classical solution. We expect that in the next few years, 3 to 5 years or so. But even now, you can get quantum ready, and your industry, whether it's in finance or logistics, or it's in healthcare and pharmaceutical research, your industry can begin deploying quantum solutions right now for this industry. And if you are interested in that, Q-Control solutions fundamentally make the applications perform better. We make that threshold of quantum advantage come closer in time. So I want to make sure that everybody gets the picture that this is not some far off fantasy land stuff that is fun science fiction. This is exactly as real as having an AWS account and logging on to use cloud hardware infrastructure. It's being deployed in the same way, so you can take advantage too.
Yeah, great.
So if I can expand just a little bit on Mike's comment, if that's okay. I think obviously it's common knowledge, or it's public knowledge, that Telstra and Commonwealth Bank are both shareholders of SQC, and so your question is, how big is industry getting involved? Hopefully that answers itself. I think also it's important that those on the call, and this is part of the way that we are touching and engaging with industry more broadly, including big industry, is by talking about this with the people who are here today. And I think it's important that no one feels like, I get Mike's sense of urgency, but no one feels like they missed the bus yet. There is time still to engage with quantum, to start that journey. We do talk to a number of corporates, and we have had these great conversations. And these things are still, particularly quantum computing is still emerging. And so no one's missed the bus. I know there's a lot of, a fair amount of news flow, and maybe being in the industry, we see a lot more of it than those without, around activities overseas, Honeywell and Volkswagen, these sort of things, where big companies are starting to engage. I still think that opportunity is emerging in Australia and will continue to emerge more. And it's something that we at SQC, for one, will be looking for more and more, as the next few years go by. And to Mike's point, I think that's right. As quantum advantage comes on, and is demonstrated and we move past that, I think there'll be, you know, a blossoming of opportunity for corporates, but no one's missed the bus yet.
Yeah. Hey, look, I think that's great, and it's a terrific reminder, you know, John and Mike. That is, you know, quantum computers are real. You can log on to them through AWS or Google or Microsoft or any of the big cloud providers. And you know, one of the nice things we have here is we actually have sort of 3 startups on the line. But Jane, I'm keen to sort of hear from you, because I know that you were involved in the UK with a lot of quantum startups. What's sort of been your experience there? Can you just walk us through a little bit and maybe give us a tad more detail on what you saw and how the ecosystem developed and what kinds of companies you saw being built? Because I think there's probably some lessons to be learned from people who are earlier in their journey and want to begin to take some of their ideas and start things here.
Yeah, sure. I know less about the industry end than I do know about the startup end and how we got these businesses up and running and off the ground. And I think what we did was we gave an opportunity to academics that were looking to do something else outside of research and to look at ways in which they might be able to commercialize the research. And I think I said last time that when we started the Q-Tech program in 2016, commercialization was a dirty word, and academics didn't want to know. They still wanted to continue with the research careers, but I think anybody that's in academia knows what a hard life it can be. And so we had 4 people come on to our very first program, and we got 4 businesses out the other end. And that was the key to the success of the program. It was, if you can do it, I can do it too. But it's a normal business building process that we took them through. We found it took 18 months rather than a year to create these businesses. The absolute key to the success was the fact that they were salaried. It wasn't so much the teaching. We found that the teaching was very much secondary. But then when the people who have been through the program came out the other end and started to run their businesses, they said, well, now we can understand why you taught us that. So it was with hindsight. The absolute key was the mentoring process that we put them through and letting them have people to lean on, both in an academic sense, a business sense, and also a personal sense as well. And we just coached and basically cajoled them through the program. The program grew in its popularity. So as we had eventually 40 come through, and unfortunately, the funding is finishing, so it won't continue. But this was all part of the UK government's investment into quantum computing, or quantum industry. So not just quantum computing. We created just one quantum computing business. The rest were using quantum to solve industry problems. So it's something that now unfortunately is going to end within the UK, because the UK's funding in quantum is coming to an end. It's had over 370 million sterling. So how this will continue in terms of the commercialization of quantum, I don't know. Bristol are trying to take it forward, but it has created a centre of quantum expertise and quantum businesses within the southwest of England. Even despite COVID and everybody having to work from home.
That sounds to me like it was a great program, and we need to go on a recruiting drive and bring all those people over here.
We're way ahead of you, Bill. I'll just throw that in.
Yeah, and maybe that leads to another question, maybe from that Peter, you and Jane can address, and that is that how did you, how did you attract people to the industry on the startup side? I mean, were they naturally attracted to starting something up, or, I know you had a program, of course, but how was that a difficult transition, or how did that sort of work?
Shall I start, Pete? It was really hard. I was not there at the very beginning of the program. Pete was part of the bid writers originally. And this is why when we were aiming at 10 per year, we only got 4, and the first 4 only came from the University of Bristol. because it's like, because you're marketing a new product. How do you reach? We had a worldwide audience, and so we're experimenting with marketing channels. It was like getting a startup off the ground. So it was hard, but it was, as I said before, that key success of those four, where people looked and saw, well, they're successful, that means I can be successful too.
Yeah, great. We also had another question, which maybe feeds into this, and that was, we had a question that says, how does an undergraduate who wants to do an internship get involved in the industry? So this is to everybody on the panel. Are there internships available at companies, at universities? How does that work if somebody doesn't know a lot, but maybe has some skill sets and wants to do an internship and learn more?
Maybe I can start from the Sydney Quantum Academy perspective. So if you go to our website, which is up and running now, we do have a section for undergraduates that lists a few of the programs at our 4 partner universities and weighs in. So we should be clear, this isn't just physics anymore, quantum mechanics. There's engineering programs, for example, at UTS and UNSW, computer science programs, and certainly physical chemistry programs, etc., that are in this space. So I mean, those are still pretty techy, but again, it's not purely in the physics space anymore. I want to also just say that the Academy's already run a summer undergraduate scholarship program. So, and this is for students really in any currently early on in an undergraduate degree in science or engineering, and they can apply to work in one of these labs. We've got over 50 quantum experts in Sydney across the 4 partner universities that submit proposals or project possibilities that undergraduate students can get into, and you don't have to have quantum tech experience at all. You know, you can be a second-year engineering student or something like that. So that's for people that are already in the undergraduate space. But even leading up to that, we've partnered with Engineers Australia, for example, who have an extensive kind of outreach network into high schools on the STEM side. And we've started adding kind of quantum component, if you like, to their presentations. So you can look out for things like that to see, you know, to get into the field, excited about the field, start hearing about the opportunities there. And we should have more, like I say, at the website and outreach events like that in the future that you can look to try to figure out where you might get in.
Yeah, great. Thanks, Pete. So one thing I was interested in, I know that, so Marcus, you know, your group comes from ANU, Mike, you come from University of Sydney, and John, you and Michelle's group comes from Silicon Quantum Computing out of UNSW. So how are the universities sort of approaching spin-outs these days? Are they leaning in to help this effort out? Has that changed since everybody's budgets got cut? What's the reality on the ground here? And who's doing a good job of this? Be interesting to hear.
Well, so for a rare moment, I will say that the University of Sydney administration did a fantastic job in supporting us to establish the company. There was a strong driver on their side to support our success, irrespective of the fact that they do not own any equity and they did not make any cash contribution or support us directly in any way. That we think was an essential step for us. If we were tethered to the university, we felt that would not make us a truly commercial entity and would slow us down dramatically because they had all these restrictions that they would nominally put in place if they were to give us $1. And when we said, look, we want to go independent in a complete way and be a completely separate commercial organization, they were supportive and allowed me to maintain my professorial appointment. So I think that was a really fantastic thing. The unfortunate reality is that is not a uniform experience across Australia. And there is a historic tendency to view any commercialization activity as a de facto conflict of interest. And that nomenclature means that you take away the one thing that motivates people to give up security and take on risk and an enormous burden personally. running a startup, founding a startup is outrageously difficult, right? If you take away the incentive that comes from the potential upside via equity ownership, then there is no reason to do this. And unfortunately, a large number of universities in Australia, not the University of Sydney, I'm pleased to say, have taken the perspective that if you own a company, you are conflicted, and therefore, it is not appropriate for you to maintain any tie to your academic role or your academic group. I think the fundamental challenge is that in government, in academia, people don't understand incentives. We're told, oh, go start a startup, right? And we're expected to start a startup just like we would write a grant or write a technical manuscript in a collaboration with someone overseas. It is just not at all the same. And because of that, the only thing that is a sufficient motivator is the commercial upside, because it is so difficult. And so I think there is some education that still needs to go on the university side, especially around IP. And I have to be fair to all these other universities and say they are only responding to the incentives that are set for them by government. They are responding to the policy settings. And so if government pushes universities to see IP licensing as a revenue stream, as opposed to releasing technology for the benefit of the prosperity of Australians, then it should not be a surprise that universities try to lock up IP and extract every dollar they can through a process which takes 18 to 24 months of licensing negotiation, over which period the commercial opportunity is largely gone, right? So I think we have work to do, but I really want to emphasize that there are serious green shoots that we've seen in more progressive perspectives taken by Sydney. And I'm sure from Marcus's success and the success of Quintessence, ANU, and I'm sure UNSW as well. But I think there is still a lifting of the game that needs to be done, but it comes from not just the universities, it comes from the policy setting in which they work as well. And this is where I want to lean on Cathy.
Yeah.
So, Marcus, if you don't mind, I'll go next. So actually, I'm sorry to hear it's been that kind of perception there, Mike. I have a different perception. I spent some time in the sector, 15, 16 years ago, and I just met Cathy, and younger back then. And I do think at that time there was a lot of the hurdles that you're talking about, but I must say in a very pleasant way, it's been a pleasant surprise since I've been here engaged with UNSW. They are a shareholder, so possibly that skews their interest. But there is a cultural difference between a startup being very focused and commercial and just trying to get the thing done, and the university, and they have different KPIs. But I think if you get your head around that and you work together, there is a will and capacity to do that. And look, it's not all plain sailing. There are moments, but we've actually found UNSW to be a very good host, landlord, counterparty. And yeah, generally the opportunity has been actually pretty good. Marcus?
Thanks, John. And so whilst I empathise with a lot of what Michael said, and also as Michael intimated, I've had a very good experience at ANU. So ANU backed my research group, which ultimately spun out the technology that created quantum brilliance, with strategic funds, which enabled us to concentrate less on publishing and focusing on technology development. And that was a strategic decision made by the ANU, specifically the Research School of Physics, to commit those funds. Those funds were also able to fund the CEO of the company, Andrew Horsley, who was able to come on board and focus on the commercialization, the construction of the startup company, and really drive the development of the company, whilst being supported by salary from ANU. And that's now ceased, of course, but it was that critical 2 years of runway, both that funded technology development as well as commercial development offered by ANU. And yes, we can all talk, we can talk war stories about negotiating exits. So it was difficult, but in the end, we got to a really good outcome with ANU. So it's been overall a very positive experience with ANU, but I do know of counterexamples, just like what Michael has described.
And Jane, what was your experience over, with your group?
It's varied, very varied. We have had some very good experiences, particularly with the University of Cambridge and Oxford, University College London, and Imperial College all have very good reputations for spinning out businesses. But despite the fact that we started a program now, we're over 12 months into our final program, and we are still fighting one UK university in order to set up a license agreement. The University of Bristol, when I first joined, as Pete well may remember, their policy was it was a straight 66% equity, which, as you know, Bill, as an investor, that's a complete no-no, you'll not come in. The policy now has changed. There's a tiered policy of 45%, 30% or 15%. As straight equity, depending on the level of influence that the level of expertise and resource the university puts into the startup. But in my view, that too is also wrong. University of Cambridge is a complete flexible policy. They all discuss with the spin out. So the UK doesn't have anything standard, and it is just so critical for when the startup is trying to get out of the university, because critically they are going to need venture capital or angel funding, and the amount of equity that the university takes can't preclude that to happen. So mixed.
Yeah, that's great. I think I'll throw in a comment here. Following up with what Jane said, if there was, and again, it's easier said than done as someone who's sitting on the outside, right? But what would be helpful, I think, is if there was sort of a standard set of agreements on how to spin something out, and it was laid out in a very simplistic way, where the arrangements were fair and equitable between all the parties. That would do a couple things. One is it would streamline the process and everybody would understand it. And the other thing is it would reduce a lot of frustration and angst, because a lot of times, my experience is when you're trying to do something like this, you can spend an awful lot of time negotiating over things that ultimately end up being meaningless and doing nothing but getting frustrated by it. So I agree, but it does sound like Mike's experience and the UNSW experience and ANU's experience with Marcus has been positive. So I'm heartened by that direction. And so I guess it's on all of you to make sure that you're highly successful, so that that kind of a process then gets floated downstream to others who want to do this in the future. Yeah.
I wanted to add something here, Bill, because often the conversation is about academics and how to coax academics out of their positions, or how to coax the universities into, say, different policy settings around IP licensing. And those are real things that really need to be resolved, as I mentioned and others mentioned before. But it's not just that, it's also the investor community.
Sure.
Because the investor community, as you well know, is used to speaking to one kind of person, and doesn't necessarily understand the motivations of someone who has dedicated their lives to scientific pursuit, as an example, and may have put 20 plus years into building a career around discovery and public good, in a way, right? Discovering things that are shared widely by publication.
Yeah.
Now, it doesn't mean that those people are necessarily by default unwilling to do commercialization. It just means that the way we approach them might be different, and the incentives and the motivators might be different. So I think we have a Australia-wide need to have greater engagement of investors with the sector, so the investors can do some work too to learn how to talk to the people that they openly proclaim they want to engage with more. I think there's learning on both sides and upskilling, if you will, that needs to be undertaken.
Yeah, it's a good point. And Peter, I think you have something to.
Yeah, I just wanted to add to that as well around the academy. So we've heard this loud and clear as well from Mike and Bill and others. So in kind of investor education is another aspect of what this Sydney Quantum Academy is recognized and our board's recognized as part of this ecosystem building. And just a few weeks ago, we had our first Quantum Innovators Network event. That one was entirely online. We are hoping in the next one which could be, I think, maybe in the next 6 weeks. So this will be a regular seminar series, getting that community together along, the academic side, the investor side, the startup side, the entrepreneurial side, and just getting together and having a talk. We had Andrew Horsley, and we had Creative Destruction Labs from Toronto, Canada, who has a quantum accelerator program, speak there, and then hopefully we'll be able to just do that community building, and we're planning to build some investor education into that as well, somewhere along the line where we can help maybe bring people along on that realization.
Yeah, great. Okay, so I think what we're going to do, I want to make sort of one last wrap-up point, and then we're going to hand it back to Rachel, who's going to do a couple things. But look, it's just from an investor point of view, since that's what I do. There's been a couple questions there. There are the investment community into this particular field is becoming larger. It's still not. It's not as, there aren't as many investors in deep technologies and quantum technologies specifically as there are, let's say, in software as a service companies, of course. So it's a smaller population. But locally, I mean, there's us, Main Sequence, there's SquarePeg has made an investment in quantum technologies. I know Airtree has looked. Blackbird Ventures has an investment in a couple of things. So the local community, I believe, is receptive to looking at ideas, and equally there are a number of firms overseas that are receptive as well, and I see that growing. Obviously, as the industry proves itself, my expectation would be that there would be more and more capital available. I'm also pleased that the federal government as well as the state governments have pockets of grants and money that are here to support the industry, and we're ever grateful that Cathy is at the helm here to make sure that it goes even faster.
Try.
So and Cyro for a long time has been an investor in this as well. And Mike, to your point, I mean, I think I do appreciate the distinction that you made. I mean, look, without the research base at the universities, many of the great tech companies would not be in existence today. And without government support, many of the great companies that were built on those technologies that came from DARPA and the likes of other government agencies supporting that deep research, many of the companies wouldn't be there today, and I wouldn't have a job. So I'm all for this. I think there has to be a recognition that, look, there are people who want to do research and stay as academics, and that's fantastic. And the world can't live very well without great scientists. And some of the community wants to step out and start up startups. That's fine too. Other people want to play in both camps. That's great too. But I do think that just from my point of view, it's terrific to see, one, that we have this audience, that we've got this participation, and this whole field is growing. And I'm really happy that to be surrounded by a group of women and men who are really taking the charge here. So I'll now hand it back to Rachel.
Yeah, thanks, Bill. And here, I just want to thank all of the contributors for sharing their expertise and knowledge today. I learnt lots more today. So thank you very much on behalf of everyone that's joined today, and everyone that will actually be able to see it over or in the future. We'll have the recording up soon. For those of you that are on the line, please, you're welcome to stay. We're about to break into small groups where you'll get a chance to talk to other people about some of the things you heard today, maybe ask more questions from some of the contributors who can stay on the line. And yes, we'll be back hopefully with more Tech23 circles later in the year. Thank you all very much. And yes, if you have to drop off, thank you. And if you can stay around, we're about to move you into random discussion groups. Thank you.